Hi class. In this video, we're going to start chapter 2. Chapter 2 is going to be about introduction to reasoning and proofs. However, before we get into mathematical proofs, which is what we'll start after this section, in section 2.1, we just want to introduce what's called the perimeter, circumference, and area. Right? These are words you probably remember from your high school classes. So we have two objectives. We want to find the perimeter and circumference of basic shapes. And then the second one is we want to find areas of basic shapes. So let's start with some definitions. The perimeter, we'll denote as P, of a geometric figure is the distance around the figure. Right? The distance around a circle, though, is given a special name. That distance around it's called the circumference, which we'll denote as C. And the area of a geometric figure is the number of square units it encloses. Now, the area of a circle is just still referred to as the area. I know, like we just saw, that circumference of a circle is different from perimeter. It just gets a different name, but there's only one area for each. Okay, so let's talk about some basic shapes. For a square has four sides that meet at right angles, and each side is equal. So the perimeter is equal to 4 times the length of the sides, S, and the area is just equal to S times S, so the side times side, or side squared. So a rectangle is kind of looks like a square, but what we notice about a rectangle is the opposite sides are of equal length, or of equal distance. So here it has length L, and this side and this side are the same, and it has width W, this side and this side. So the perimeter is equal to 2 times the length, because there's 2 L's, plus 2 times W, because there's 2 W's. Or we could write it as 2 times, in parentheses, length plus width. The area of a rectangle is just equal to length times width. That's it. For a triangle has sides A, B, and C, right? And the height of the triangle, right, goes from bisector of one angle all the way down so that it meets a right angle here, right? And we'll call that the height H of the triangle. So the perimeter is just A plus B plus C, the sum of the sides. The area is equal to 1/2 times the base of the triangle times the height. And you know the base because that's where the height comes down to, and it doesn't go through an angle. Circle has radius R and diameter D. So the diameter is the length all the way across. The radius is really just 1/2 the diameter. So the circumference is equal to pi, which is just a constant, right? That's the number 3.14 dot dot dot, right? Pi times D, or C, is equal to 2 pi R. We'll probably use this one. So 2 pi times the radius. The area is equal to pi times the radius squared. That's it. You should keep these formulas handy with you throughout the rest of the class. Let's do some examples. Right? Finding the perimeter of a rectangle. So the Botany Club members are designing a rectangular garden for the courtyard of your school, right, as shown right here. They plan to place edging on the outside of the path, right? So how much edging material will they need? So what I'm talking about is they want to put this red edging here, right? So how much edging will they need? So what we want to do is we want to find the perimeter, right? So the red line about the outside of the path is where the edging is to be placed. Right, so as I said, what we want to do is we want to find the dimensions of the rectangle formed by the edging. So we need to find the perimeter. All right, so first off, we need to find the width. So if you look here, this gravel part around the garden, right, is all 4 feet. So the width here, we see that the garden is 16 feet, but then on each side is 4 feet. So that means the width for this edging is 4 plus 16 plus 4 is 24. That's the red length there. The length of the garden, using the same thought process, the garden itself is 22 feet, and then there's 4 feet on each side. So the length of that garden there will be 4 plus 22 plus 4 is 30. So to calculate the perimeter of this rectangle, we're going to use that formula 2 times the length plus 2 times the width. So 2 times 30 plus 2 times 24. That gets you 60 plus 48. So it's going to need 108. We need 108 feet of edging material. Next, what is the circumference, of each circle in terms of pi? Right? And then what is the circumference of the circle to the nearest tenth of a degree? So we have circle here M and circle here T. All right. So the diameter of circle M is 15 inches. So the circumference is pi times the diameter. So in terms of pi times 15 is just 15 pi. Okay, so we just say the diameter is 15 pi. Now to put that in terms of to the nearest tenth of a degree, if you do 15 times pi in your calculator, there should be a pi button, or you could use 3.14. You get 47.1238. So the nearest tenth of a degree here, that would just be 47.1. For the next part, I want to find the circumference of circle T. Well, the radius of circle T is 4 centimeters. So we're going to use circumference is equal to 2 pi r. So 2 pi times 4, that gets me 8 pi. Now that's in terms of pi. But if I wanted to figure it out to the nearest tenth, 8 times 3.14 gets me, whatever pi is, gets me this. So it would just be 25.1. All right, let's talk about an coordinate plane. So what is the perimeter of this triangle? So triangle EFG. All right, well, what we need to figure out here is the distance of this length, the distance of this length, and the distance of this length. And then what we need to do is we need to add them together. All right, so find the measures of each side. So EF, you're going to find the difference between up here 6 minus 2. All right, and then you're going to take its absolute value because it's a distance. So 6 minus 2, that becomes plus. So its absolute value of that is 8. Same thing over here. Now because we're along the x values here, over here we use the y, so we use the x from FG. So it's going to go from 3 to negative 3. So it's going to be 3 minus 3, or 3 plus 3 is 6. Then we're going to have to use the distance formula here to find the length of EG. So you're going to take the x values, 3 minus 3 and square it. So that becomes 3 plus 3. All right, so that's going to be 6 squared. And then 6 minus 2. Right, so that's going to become 6 plus 2, or 8. So you're going to get the square root of 6 squared plus 8 squared, like this. That's going to be 36 plus 64. Square root of 100 is 10. So add the side lengths of the triangle to find the perimeter. So if you add up all these sides, 8 plus 6 plus 10, the length of this, the perimeter of this triangle is 24 units. All right, let's do another example. All right, we want to make a rectangular banner similar to the one on the right. So I have this one about San Francisco. The banner shown is 2.5 feet in width and 5 feet in length. Right? Now this is, you've got to be careful. This is tricky. If we round up to the nearest square yard, how much material do we need? Now here's how this problem is trying to trick you. They give you the dimensions in feet, right? But then they want you to put it in terms of square yards. That gets a little bit tricky. All right, so since we asked to find the area in square yards, let's first convert the dimensions of the banner to yards. We will use a conversion factor to do this. All right, so we have the width. We're going to take 5.5 feet, right? Because that's what we said here. 2.5. So excuse me, not 5.5 feet. 5 divided by 2 feet. You just turn 2.5 to 5.5. You're going to multiply that by 1 yard is equivalent to 3 feet. Multiplying across 2.5 feet, or 5/2 feet, is equal to 5/6 of a yard. The same thing with the length. You're going to take 5 feet, multiply it by 1 yard, divided by 3 feet. You get 5/3 of a yard. So to find the area, you do length times width. So area is equal to 5/3 is the length times 5/6 is the width, or 25 over 18. All right, so you're going to need, if you were to plug that in, you can't divide evenly, so you can't get less than a full unit. So you're going to need about 2 yards of material. criteria for this. All right, let's just do one more problem. Let's talk about finding the area of a circle. Find the area of the circle in terms of pi. Right, so the diameter of the circle we see is 16 m's or 16 meters. Thus, that means the radius is divided by 2, so 16 divided by 2 gets me 8 meters. So area is equal to pi r squared. So plugging in, 8 squared gets me 64, so it's just 64 pi right there.